All right, today we're talking about compound interest. In middle school, you guys should have talked about simple interest. So having a principal amount, ending up with the amount at the end. So in middle school, you talked about simple interest, okay? We're talking about compound interest now. At the top of your page, I'm going to pause and let you write down the compound interest formula. So here is our compound interest formula. So at the top of your notes, you should have a whole section from yesterday. Okay, so you have plenty of room to write this down, if I remember correctly.
Right on this little forehead.
Yep. At the top of your page, you should have a whole little rectangle space to write it down.
It's the forehead.
Okay, so you should have written this down. As you can see, A represents our amount. That's your ending value, right? It's your output. P is our principal, your initial amount. What did you start with? Your R is your rate, your interest rate, and we write it as a decimal, not as a percent. And your N is your number of times interest is compounded per year, okay? When you are saying compounded, is it twice a year? Is it 3 times a year? Is it 4? 4 meaning quarterly. Is it biannually, which means twice? How is it being affected? Like, how is this being applied to your amount, okay? And then T is for time in years, okay? So if you have 6 months, how would I write that in terms of a year? A half a year. Does that make sense? So your time is in years. Got it? Not months, but years. Capiche? All right. Here we go. Let's look at our first problem. So our problems are broken down into, I'm going to completely do the problem. Then you're going to do a problem with your peers, and then you're going to completely do a problem. Okay? So that's how it's broken down. Up first, we're going to talk about our friend here, Pierre. Pierre invests $1,000 in an account that earns 15% interest compounded quarterly. Suppose that he makes no deposits and no withdrawals. Write an exponential function that you could use to determine the account balance after T years. Then use it to determine the account balance after 10 years, okay? So again, we're working with A equals P times 1 plus R divided by N to the NT. Okay, so I'm going to read back through and mark my text. So reading back through and marking the text, I have 1,000. 1,000 represents my P, my principal amount, my initial investment. All right, so we're at 15%. So the 15%, this is going to be my R. Does that make sense? This is my interest. So R is going to equal 0.15. Agree? Okay. Compounded quarterly. Quarterly means I have how many parts? 4. So N equals 4. So I went through and I marked up the text to find all the key things that I need in order to write my function. Ready? So we have A equals, our P is 1,000. 1 plus our R is 15%, 0.15. Our N is 4. So then that leaves us with 4T. So that's your exponential model.
And then up here, do we put 10?
And then we're going to solve it. So the first thing they told us to do is to create a model in terms of T years. Did we create a model? Yeah. Now it wants us to know, after 10 years, how much does he have in his bank account, right? So we want to know, after 10 years, what are we working with? And there's a couple ways of doing it. I can substitute in 10. I can put this into Y1, and I'm going to model both. So if I'm substituting in 10, I have 1,000 times 1 plus 0.15 over 4. 4 times 10, right? That's easy enough. That's the substitution way, right? The other way is I'm going to plug my original into the calculator. To the calculator, Y equals. Y equals. Okay, so let me pull up my calculator. So here's my handy dandy calculator. I'm going to clear 2nd plus 7, 1, 2. So when I have Y equals, I'm plugging in this guy right here. So 1,000 parentheses 1 plus 1500.15 divided by 4, close parentheses. Yeah, I can't. It didn't. To the 4t. Now, if you notice right here on my variable button, it has x, t, theta, and n. I'm gonna press this, but it's gonna look like an X, and that is okay because I'm graphing the function. Does that make sense? All right, so I'm gonna have 4, and it's gonna look like an X because in the calculator for graphing, that's what it comes out to be. All right. And then I'm gonna go to the table, second graph, and I'm gonna look at the value of 10. That's how you get to your table. Hopefully we know that by now. Okay, so once I'm there, I now can clearly see my value. Okay, so after 10 years, how much is Pierre expected to have in his account? And 38 cents. Okay, to get the value accurate, you arrow over to the Y and you can see the full value at the bottom. Okay. Now I'm going to model it from the calculator page. So on the calculator page, I would just type this in 1000 parentheses 1 and 1500 divided by 4 close parentheses to the 4 times 10. And do I get the same thing?
Yeah.
I do. Okay. All right. How do you feel?
Did you put like to the power of 4 plus
I put 4 times 10.
10? Oh.
Okay. All right. So in game, if you're going to use y equals, then you're going to use the table to get to the table. That is second graph, right? So if you're going to choose to get to the table, and that's going to take you to your table and analyze the table. Pass. Okay. Any questions, comments, or concerns? So we know A of t equals $4,360.38 is what his account has built. All right. Cool. Terrible. What makes it terrible? Oh well. Not wanting to do it is different.
I think
all right, so on the peer do, so at your groups in your table, this is not time to pull out your phones, talk about other things. I would like for you guys to figure out Maria's dilemma. The key thing here is that you are creating 2 exponential function models because Maria is comparing. She wants to know which one's going to give her the better deal, okay? So you at your table, you're going to create the 2 exponentials and make a comparison after 20 years, which is giving her the better deal. So read through. You're going to read through, mark your text, create your function models, and figure it out. Got it? All right, I'm going to give us 5 minutes on the clock. All right. Here we go. Let's see how we did. So Maria had 2 choices and two different bonds. So beginning here, marking our text, your 100 was your what value? Our initial, our P value. Good job. Then we have savings bond in long terms. So she's going through and she has 2 choices. She has bond A right here, and it has a 2% annual interest. So that 2% is our first R, right? And it's annually, so that means N equals 1. Bond B has a return of 1%. So that's our R2. And it compounds semi-annually, and it told us that means twice per year. So that means our N equals 2. So I have 2 different models here. So the first one for bond A, I'm just gonna write an A. A is gonna equal 100 times 1 plus 0.02 over 1 to the 1 times T. Agree? All right, bond B, I'm gonna write as B equals 100. Good job. Over 2. 2 to the T, right? So now we have our models, and it wants to know, comparing them after 20 years, which savings bond will have worked the best, right? So we're looking for, what does it look like when T equals 20? Since I have 2 of them and I don't want to type it more than I have to, I'm going to put it into Y equals and compare the table. So I'm going to go to my handy dandy calculator, turn it on, and in Y equals, I'm going to put in 100 times 1 plus 200 divided by 1. And I know I don't have to, but I'm just putting everything in just so that I don't break any routine of writing anything, right? X. I did write 0.02. And then I'm going to do Y2. So I have 100. 1. Guys. Plus divided by 2 to the 2x. Okay, and again, in order to look at the table, I'm going to hit second graph, and I can scroll down and compare, right? And after 20 years, which one did I make the most money with? Bond A. So bond A has me making $148.59. And bond B has me making $122.08. So obviously I'm going to take my money to bond A. We got 148.59, and on B we got 122.08. Yeah, it's compounded at 1%, and she only invested $100. She was just trying to help her community out.
Just help with inflation.
Yeah. You know, she did her part for the community. All right. So what you're going to do, and this is your self-check. The challenge here is for you to do as much as this independently. Okay. So as much as you can, completely independently, you're going to figure out which loan should go with. Okay. All right.
The one that has the least price.
Exactly.
That's why you don't want to.
All right. So I walked around, saw a lot of good things happening. Things that I just want to point out is that when we are doing these individual practices and you're not doing them, that's a problem. Okay. Part of this class being in pre-AP means that you are going to be self-motivated and do the work. Okay. If you're not doing the work, it's going to be a really hard class for you to be fully successful in. All right. So here we go. Needs to borrow $10,000 to purchase a car. Now, when you're shopping for a car, do you want the loan that's going to make you pay more? No. So our goal is to figure out which loan is he going to have to pay the least amount on. Does that make sense? So from reading and marking your text, you should have that this was your p-value. Agreed? At one bank, so at bank 1, here's its rate, and its rate is R1 equals 0.02, right? Compounded twice per year, so N equals 2. And then at another bank, its rate was 4.04, and it was compounded once, so it's N equals 1, right? So I'm going to have my 2 banks. Is it okay if I call them Bank A and Bank B? And his loan is for how long? 5 years. So we're comparing when T equals 5. So you should have had Bank A was at 10,000 times 1 plus, please get off the phone right now. Plus And then make sure, another thing that I noticed while walking around is some of y'all are forgetting your N. It's NT, right? Your power is N times T. So make sure you're putting that. We have B equals 10,000, 1 plus 0.04, and it's compounded 1. Okay? So after you do that, then you have to just plug it into the calculator, and we're looking for T equals 5. Okay? So with bank A, what did I get when T equaled 5? 11,046 and 22 cents. Bank B, what did it give me? 12,000 what? 66? There we go. All right. Well, I wrote my cents, so 53 cents. All right. So which bank should I go with if I want the best bang for my buck? Bank A. You want to pay the bank more money?
Yeah.
Oh, okay. Cool. All right. Don't let me stop you. All right. So that's how that's calculated. Yeah. Doable?